Every second of every day, tension along plate boundaries builds below the Earth's surface until the time comes for a rupture. 2010, a devastating earthquake kills over 300,000 in Haiti. 2011, Tohoku, a magnitude 9.0 earthquake and resulting tsunami lays waste to Japan's coastline. It is the most expensive natural disaster in history. 2012, Northern Italy. Tens of thousands are left homeless after a 3-week sequence of earthquakes. Southern California might be next. LA sits on a web of crisscrossing faults, all capable of powerful earthquakes. The San Andreas Fault, the largest of them all, ruptures on average every 150 years. However, the southernmost portion hasn't ruptured since 1680. One major effort to protect Southern California from this inevitable disaster is taking place at the Southern California Earthquake Center, headed by Tom Jordan.
SCEC is a very large collaboration comprising over 600 scientists from more than 60 institutions who are trying to understand the earthquake problem, but also trying to translate that information into practical products that can help protect society from the earthquake threat.
One program that demonstrates this approach has college students from across the country work together to advance earthquake information technology, the USEIT Summer Internship.
The Undergraduate Studies in Earthquake Information Technology program is a collaborative internship where students are working on a single project called a Grand Challenge.
Every year, they come through with remarkable progress towards some very important scientific goals.
One significant achievement has been the students' creation and development of SCEC VDO, an earthquake visualization platform.
Our grand challenge for the year was to add a time axis to the SCEC VDO program.
In 06, it was primarily working on our 3D visualization software, allowing people to play earthquake sequences and record at the same time.
Over the years, SCEC VDO has become incredibly powerful, allowing users to visually manipulate the dimensions of space and time, overlay GIS maps such as hospital or power plant locations, import data sets from online earthquake databases, and much more.
SCEC VDO is a really amazing system, and it's remarkable that it's been entirely developed by undergraduate interns during this relatively short 8-week summer program.
Over the past decade, SCEC VDO has played an important role in the creation of the rupture forecasts that determine California's building codes, insurance rates, and emergency response plans. And now, this student-developed software is helping scientists to build the most advanced rupture forecast ever made, USERF-3.
The biggest thing for my project is the SCEC VDO software. We have scientists using that every day. Couldn't do it without it.
USERF-3 wouldn't exist if it weren't for SCEC VDO. There were times where we had Skype conference calls where 4 of us were in different locations, all having SCEC VDO in front of us and talking about something we were looking at.
Just in my program, we had mathematicians, computer scientists, we had geologists. That really helped us to accomplish our goals.
We worked with such a diverse group of people that this was like their very first taste of earthquake science.
Going into USEIT, I had taken an Introduction to Geology course and also a Petroleum Geology course.
I knew nothing about earthquakes. I thought I knew what a fault was, and when I stepped into USEIT, I realized that I had no idea what a fault even is.
USEIT more than anything else, and this is the way I think of it all the time, it's like running SCEC in miniature. It's pulling together all these different minds that have many different backgrounds to attack a very complex problem, meaning the earthquake problem, and to be able to answer this. And it's only going to happen through a multidisciplinary and a multi-mind basis.
One of the things that I really appreciated about my time here as a USEIT intern was the opportunity to work with computer scientists and scientists.
We were given a very big grand challenge without particular requirements as to how we get to the end result.
It was basically up to us to come up with a solution. So that was challenging, but it was good because we had a great team. Some people were knowledgeable in one thing and some were in the other.
Did it add stress? Yes, it did. But I think, again, that comes with anything that you're going to do.
You know, sometimes there are personality conflicts, there are practical issues with coordinating work with 20 people, and everyone has their own specialty.
So I was able to pose a problem to our resident mathematician, if you say, solve this, and he did, and then I was able to implement that in our navigation package.
One of the remarkable aspects about the USEIT program is how it builds student confidence. By working together in teams, doing real research, they realize that they can contribute in ways that they didn't know they could. I watched them actually become scientists in the course of a single summer.
I learned a lot from the USEIT program, not only about programming and about earthquakes, but also about teamwork.
The most rewarding thing in working with the students has been seeing people grow over time, seeing people achieve new things, go on to graduate school, win awards, present papers. So for me, it's much like being a teacher where you see your students do bigger and better things than you ever could.
USEIT was definitely the turning point in my career.
One of the reasons that I continued working at SCEC is because I found from that summer that I really enjoyed working with both computer scientists and scientists.
I can say with full honesty that I wouldn't be sitting here today if it wasn't for USEIT.
USEIT definitely had a huge impact on me.
I would have never thought that working with earthquake science was going to be an option, but now it's more than an option. It's definitely a very likely opportunity.
Many students over the years have gone on to work with other faculty at other institutions, and they'll become the professors, the researchers, the policymakers, the filmmakers of the future, and they'll be able to tell the earthquake story effectively.